You have to do them to demonstrate that you understand the topics. These tests will count to your module mark, and I think they count for 1% each for this BI 308 module. But you can do the tests as often as you like, and only the best score will count. In order for the score to count, however, you need to have 80%. If you have less than 80% in a test, it will be counted as 0. Right? But as I said, you can do them as often as you like. And the deadline for this is Star Wars Day, which is May the 4th. Be with you. Next year, obviously. So you've got plenty of time, but I suggest that you do these quizzes as you go along. I don't expect you to do all of them right now, because there are some topics that we haven't covered. Of course, you can try and see how much do you know about it, but it's not, don't be disheartened if you don't get a great score at the moment when we haven't covered the stuff. Okay? Does that make sense? There are sign-in sheets in circulation. Please make sure that by the end of this session, your name is on the sheet. That would be great. And otherwise, hey, let's talk a little bit about what you did in the practical. And there's one topic that you probably haven't really appreciated during the practical, simply because I haven't harped on about it. But that topic is absolutely essential to understand for bioscientists. Actually, for everybody. Everybody really should understand this particular topic. And this topic is called correlation. And really, this is what we do as scientists. We constantly make correlations between data. Now, the correlation that you did was actually you added water to the tubes and weighed them. So you made a correlation between volume of water and weight. And obviously, what you discovered was hopefully, that there is a positive correlation. The more water you put in, the heavier the whole thing is. And that's a typical characteristic, this phrase of a correlation, the more. Yeah? So what you should have discovered is, if you plot the volume here in, let's say, milliliter or microliter or whatever the unit, and you measure the weight, that would be usually gram, what you discover would be probably something like that, with your individual data points, something like that. Yeah? Did you get that? I hope so. If not, there was something seriously wrong. Now, because this line, bless you, because this line goes up, and for high volumes we get a high weight, we say there is a positive correlation. So we are looking at the sign of this correlation. Likewise, you could think of negative correlations. So, for example, nights in the venue and amount in my wallet. Yeah? And you can imagine that it looks like that. Is that fair? Yeah? And because the line goes down, this is called a negative correlation. The more I spend, the more nights I am in the venue, the less money I have. Negative correlation. Pretty easy to understand. We do that all the time. Now, sometimes we want to know if there is a good, if there is a very good, or if there's no correlation between data. And to make this correlation, people have invented a sort of a score. This thing is very often called Pearson's R-score, or Pearson's coefficient, or correlation coefficient. Correlation coefficient. And it usually is abbreviated with an R, at least for our users. And this R can assume any value between -1 and +1. So anything in between. Now, what does that actually mean? If we have, for example, something that is a perfect correlation, something like that, where all the data are really bang on a straight line, we would assign this as a correlation coefficient R equals positive or negative? Positive. 1. This 1 means everything is bang on. Yeah? What about something like that? Is it bang on? No. Is it positive? Yes. So R equals positive, smaller than 1. Let's say in this case it would be 0.95. So this indicates it is still, would you say it's a strong correlation in this case? Yeah. We would probably call this strong correlation. Strong but not perfect correlation. What about this? What's that? What R value would you assign to that? R equals exactly -1. So the negative indicates it is a negative correlation. And because they are all on the same line, it's perfect correlation. How about this one? Are the data correlated? No. So in a way, what we could actually sort of draw a line like that and say, in this case, the data are not correlated, plus or minus. It's probably R equals 0. That means if you see R equals 0, data are not correlated with each other at all. Yeah? And there are certain quite arbitrary rules where people say, for example, R equals 0, no correlation. That's easy. No correlation. R equals +1, perfect. R equals, let's say, 0.9 to 1, very strong correlation, and so on and so forth. Yeah. When we are working as scientists, very often we want to see what is this correlation coefficient when we do some measurements. How do we calculate this correlation coefficient? The equation for this thing is nothing for the faint-hearted. So I do not expect you to know this equation. If you do, great. I don't. If you want to really impress me in a test or something like that, write down the equation. But honestly, why occupy memory? You can look it up. But very often in scientific publications, you will see an R value. And that indicates how good the correlation is. You can actually calculate the correlation with Excel, because Excel allows you to put in what is called a trend line. So if you've got data like that, let me get this. If you've got data like that, then Excel can actually calculate what is called the line of best fit. And the way Excel does that is just simply by, in the first place, trial and error. It tries to calculate a line, for example, something like that. Actually, humans are pretty good at doing that. Yeah? If you've got several points, you can very easily sometimes say, oh, right, the line should actually go like that. And intuitively and instinctively, we find very often a line of a really good fit, whether it's the best fit. For a computer, this is terribly difficult. But Excel has a way of dealing with that, because what Excel does is it says, right, I've got this point here now, and I've got a corresponding point here. Yeah? Now let's just simply count what is the difference between this one and this one, and keep that to a minimum, this difference. And actually, Excel does that, I think for the line of best fit, it does about 100,000 calculations. Try to minimize this difference. So then it says, okay, this difference is quite big. Maybe if we put the line like that, the difference gets smaller for that point. It's pretty good for that point, but it's very big for that point. So maybe we need to do a little bit of iterations. This is basically what Excel does. And if you want to actually do this line of best fit, there are lots of YouTube tutorials. Actually, it's very easy. What you need to do really is right-click with the mouse. Right-click with the mouse on one of the data points, and then you get another menu, and it says trend line. This is what it's called in Excel. And it also, in Excel, it gives you an R value when you do that. So you tick the box R value. A slightly annoying thing is that very often people don't give you an R value. People frequently give you an R square value, which is basically the R value squared. There are some reasons for that which are not important. I think it's a little bit, I don't like it very much, the R square value, because the information, whether it's a positive or negative correlation, disappears. Because if you square a negative R, small r, it will be always positive. So this information gets lost. But never mind. Some people do that, and Excel unfortunately does that as well. So if you, depending on what you are asked for, whether you are asked for the small lowercase r or the capital R square value, you know how you can convert them into each other. Okay? Does that make sense so far? Okay, so as scientists, we constantly try to figure out these correlations. But correlations can be dangerous. Correlations can be very misleading. And we have lots of examples how they are misleading. Here is a beautiful example. In the 1950s, scientists did an analysis in Sweden, and they looked at the number of breeding storks the number of babies born. And the babies here is human babies. And guess what they found? There was a very strong correlation. R equals 0.92. So there was an extremely strong or very strong correlation between the number of storks and the numbers of babies. What's your conclusion?
Babies come from storks?
Absolutely right. Yeah? The conclusion is storks deliver babies. Okay. Ty just asked, is that true? Are you studying biomedical science? Right. Shall we have a chat afterwards? Yeah, because, you know, the bees and the birds and the flowers and things like that. I think we probably... So, what people did was they saw a correlation and said, oh, actually, there is a causal effect. Because there are more storks, more babies are born. This is one of the biggest pitfalls. This is just simply not true. And the mantra really is, correlation is not causation. Very, very important that you always bear that in mind. The correlation is just simply the data. This is what the data show us. There is a correlation. Causation means that one variable is causally related to the other one. Here's another one in a slightly different format. And there is a website actually dedicated where you can find what is called spurious correlations. Well, actually, the correlations are not spurious. It is just simply, there's no cause and effect between the variables. So, one is the marriage rate in Alabama. That is one of the lines. Can't see it properly. And the other one is the consumption of whole milk in the US. So, and that is shown over a period of time. Now, this is a slightly different way of presenting the data. I want you to tell me, do we have a positive or a negative correlation here? What is it? Positive or negative?
Positive.
It's a positive correlation. Whoa, wait a moment. The lines go down.
But they both go down.
Sorry?
But they both go down.
They both go down. Exactly. So they do exactly the same thing. Yeah? Or in other words, the more milk we have, for example, in this particular year, the more milk we drink, or the Americans drink, the more marriages there are. The more, the more. So it is a very good positive correlation. What we can actually do is, we could entice the Americans to drink more milk, and then sooner or later, the state of Alabama will be have loads and loads of marriages. Could very well be, couldn't it? So of course, it's completely bull. But this is what people could infer from that. A little bit more sinister. Unfortunately. And What people discovered or have known for a long, long time is number of cigarettes smoked versus number of people dying of lung cancer. What do you think? Is there a correlation? What would you expect? Correlation? Yes or yes? Yes, there is a correlation. The data very clearly indicate that there is a positive correlation. Would you expect this correlation actually to go through the origin? No, why not?
Because people will die of lung cancer anyway.
People die of lung cancer even if they haven't smoked their entire life. So we would not expect it to go straight through zero, but it would be probably something like that. So there would be a very good correlation. Because of this correlation, many people have tried to sue the tobacco industry and say, you have sold me some stuff that is very dangerous for my health. Have they been successful? In most cases, people have not been successful. Why?
Because people can get lung cancer no matter what they do.
People can get lung cancer, exactly, because it is not going through the origin, no matter what they do. And also, the tobacco industry said, wait a moment, there is a correlation. But there is no causation. You cannot prove that actually the number of cigarettes that somebody smokes will lead to lung cancer. So you cannot prove that. Very often you think, oh, a correlation, it's absolutely clear what causes it. But proving a cause and effect is extremely difficult. And that is why still there are cases, court cases going on, where people try to sue the tobacco industry and with no effect. Because it is so difficult to actually find and prove beyond doubt the cause. Another issue is that sometimes we are not really looking at the right level of the data. And this is actually something, what I'm showing you here, this correlation stuff, this is incredibly, how shall I say, this is an incredibly sexy topic at the moment. You might not think it is sexy, but this actually will revolutionize our understanding of the world. Making these connections, making correlation, doing what is called data science, and finding these correlations. Again, seeing a correlation does not mean that there is a causal effect, but then us scientists come into play and say, right, there is a correlation, we see that, let's see what is the underlying issue for that. Now, last year, I asked one of the final year project students actually to look into that a little bit and use correlation analysis, data science, and social media to find correlations. Sounds bizarre, huh? How social media? Well, he started off with looking at trends. He looked at search engine results, and we said, okay, let's have a look at, for example, how often does somebody look for a certain term over time with the search term depression in it. And you can do that either through Google, and there is a fantastic function which is called Google Trends. It's available to everybody. So, Google Trends, you can do that also with Twitter. How often do people tweet something with the hashtag depression in it? And he got this line here, this graph. Now, what does that tell us? It doesn't tell us an awful lot. It tells us that occasionally you've got dips on certain days. You've got an interesting peak here. That was actually the 26th of August, 2017. On that day, people in particular looked for depression. So it wasn't a really good day for them. And with Google, you even can find out where it happened, where did people actually look for that, and predominantly it was in the US. What happened on the 26th of August? Anyone? That's just 2 months ago. The hurricane season started with Hurricane Harvey going through Texas and flooding Houston. Yeah? This could explain why there is this peak on the 26th. Yeah? There's no proof for it. We would have to ask people, actually, why did you Google depression on that particular day? Well, we don't have any proof, but it is a likely explanation. Well, actually, these data don't show us a lot. So I said to that student, maybe we are looking at the wrong scale of the whole thing. So we are looking from basically 16th of October until the 11th of October this year, 16th of October last year to the 11th, so a whole year. Maybe we need to look at a finer scale. And he did. And then I said to him, oh, there's something interesting in the correlation. Maybe you can figure out what it is. And Google Trends allows you to compare two keywords. And we said, okay, let's compare depression and stress. Do you think there is a correlation between depression and stress in people? The more people are stressed, the more depressed they are. Do you think? Yeah? Let's see what he found. This was what his finding was over the past 90 days. The blue one is depression. The red one is stress. What would you say? Is there a link between depression and stress? Is there a correlation between it? Yeah? What is it? Is it a positive or negative correlation? It's a positive correlation between the two because the two lines do exactly the same thing. It's amazing. And again, you see, 26th of August, people who are actually not stressed, there's an interesting thing. People were not stressed, but they were depressed. But that's the only outlier in a way. Do you also notice something when you look at the two lines? What's happening? Yeah, you are doing the... What's happening? You see peaks and troughs. And both stress and depression do exactly the same thing. They follow a very distinct pattern. And again, this is something that we as scientists are trying to do. We figure out patterns. So the big question is, why is there this periodicity in it? Why is there a pattern in the correlation? What could be the cause? This is where the human element comes in. Because machines, as clever as they are, currently can't make these connections. You very clearly see the pattern. What could be the reason for this pattern? Any ideas? Okay, I'll help you. The difference between these things is exactly 7 days. Does that help you now?
It's at the end of every week.
It's at the end of every week.
So over the weekend, people are less stressed because they don't have...
You are absolutely right. At the weekend, people are less stressed. And therefore, feel less depressed. I thought that was quite interesting. He did another experiment as in data query, where he looked at the frequency of people Googling emergency contraception. What do you think he found? He found exactly the opposite pattern. Weekends, emergency contraception went up. During the week, down. Weekends up. So, there is a clear correlation between stress and depression. Strong positive correlation. And a strong negative correlation between depression and emergency contraception. So, what we can do, for example, is, with that, we can make some conclusions from it. But we mustn't forget, it is only our own interpretation of the data. There is no necessarily a contraception. A causation. Maybe, it could very well be that because over the weekend they were doing it like rabbits, they felt less depressed. Conclusion could be sex is good against depression. It's worth testing, isn't it? Yeah? Sex is good against stress. Well, we know that. What bothers me is then the emergency contraception, but the emergency in it. But, that's a different story. So we could come to testable conclusions from that. And I said to him, because this guy was from Nepal, I said to him, right, this looks great, where we have depression and stress following this weekly pattern. And if you look at it, the low point here is always the Sunday. I said to him, let's have a look at how this looks for other countries where we don't have exactly this working week pattern. So he did this analysis with a specific location in mind where people have a different working pattern. So he looked at Israel, where the weekend starts on Friday to Saturday, and Sunday people work again. He also looked at Nepal, where people still have the weekend, Saturday, Sunday, but, there might be other factors. The interesting thing that he found for Israel, you would expect that people are less stressed Friday, Saturday. There was no cyclic pattern. Bizarre. We still don't know why. Are they constantly stressed? Could be. Maybe it's because of the political situation. I don't know. Nepal. No cyclic pattern. There was actually in Nepal, we found there is no correlation whatsoever between stress and depression. And you think, flaming heck, what's going on? What do they know that we don't know in Nepal? Are they more chilled? Maybe they don't have internet. Well, I think that's an assumption that goes a little bit too far, because we can actually count the hits. And yes, people are less inclined to use the internet, probably in rural areas in Nepal. But nevertheless, from the few data that we have, we still see there is no correlation. Maybe, and that is only a suggestion, maybe there is one thing that the Western world is more tuned into the issue of mental health and depression. That's why we see such a correlation. Maybe in the Western world, we are under more pressure and see this correlation. So what you see basically here is something that looks really, in a way, almost innocent, there is strong positive correlation here, but at the same time, it opens a whole can of worms. And that is, in a way, that is the take-home message for you. Always look at the data. Is there a correlation? Correlations are easy to find. Causations are extremely difficult. And it would be really interesting to see if somebody can come up with some explanation that we could test. That is what we do as scientists. I hope you enjoyed that, and it made you think a little bit. I shall see you tomorrow. Can I have the sign-in sheets back, please?